Namaste to everyone. I welcome you all in my YouTube video channel. Today I will deliver lecture on special theory of relativity. Lecture number 5, in which I will solve some problems related to Lorentz invariance. Now we solved a problem. Problem is prove that four-dimensional volume element dx, dy, dz, dt is invariant under Lorentz transformations. Now we solve this. Solution. Since from Lorentz Invariance contraction we know that L prime equal to L by beta. L prime is x2 prime minus x1 prime 1 by beta. This is L equal to x2 minus x1, implies that dx prime equal to 1 by beta dx. Here x1 prime, x2 prime are coordinates of endpoints of the rod, and L prime equal to length in S prime system, and x1, x2, L be corresponding quantities in S system. This is number 1. From time dilation, delta t prime equal to beta delta t, implies that dt prime equal to beta dt. This is number 2. Since dy prime equal to dy, dz prime equal to dz, therefore dx prime, dy prime, dz prime, dt prime equal to 1 by beta dx. This is dx prime. dy prime means dy, dz prime means dz, dt prime means beta dt. This is equal to dx, dy, dz, dt. Therefore, the value of the volume element dx, dy, dz, dt is same in both system. That is, volume element dx, dy, dz, dt is invariant. Proved. Now we solve the next problem. Next problem is so that ds square equal to dx square plus dy square plus dz square minus c square dt square is invariant under Lorentz transformations. Now we solve this. Solution. Since by Lorentz transformation x prime equal to beta x minus vt, y prime equal to y, z prime equal to z, and t prime equal to beta t minus vx by c square, implies that dx prime equal to beta dx minus vt, dy prime equal to dy, dz prime equal to dz, dt prime equal to beta dt minus v dx by c square, where beta equal to 1 by square root 1 minus v square by c square. Now dx prime square plus dy prime square plus dz prime square minus c prime square dt prime square, this equal to dx prime square means beta square dx minus v dt square plus dy prime square equal to dy square plus this is dz square, c prime is c square, and this is beta square dt minus v dx by c square whole square, this equal to beta square, here whole square dx whole square minus 2v dx dt plus v square dt square, and here we take common beta square, now remains c square here, and here whole square dt whole square minus 2v dt dx by c square plus v square dx square by c to the power 4 and plus dy square plus dz square, this is equal to beta square dx square minus 2v dx dt plus v square dt square minus c square dt square minus c square cancel, minus minus plus 2v dx dt, here minus c square, here c to the power 4, so remains minus v square dx square by c square plus dy square plus dz square, and this will be equal to beta square, here we take common dx square square 1 minus here v square by c square, here minus 2v dx dt, here plus 2v dx dt cancel, here minus c square dt square, here v square dt square, we take common here minus c square dt square. So remains here 1 minus v square by c square plus dy square plus dz square. This is equal to beta square. Here this is dx square, and this is here beta equal to this. So this is 1 by beta square. 1 minus v square by c square is 1 by beta square. 1 by beta square equal to 1 minus v square by c square minus c square dt square. This is also 1 by beta square plus dy square plus dz square. So this will be equal to beta square cancel, dx whole square minus here also beta square cancel, c square dt square plus dy square plus dz square. This equal to dx square plus dy square plus dz square minus c square dt square. So in both system this quantity be same, since d square equal to dx square plus dy square plus dz square minus c square dt square, and this equal to this equal to dx prime square plus dy prime square plus dz prime square minus c prime square dt prime square. Therefore ds square equal to dx square plus dy square plus dz square minus c square dt square is invariant under Lorentz transformation. Here we see in both system this quantity be same. So proved. Now we solve the next problem. Next problem is so that x square plus y square plus z square minus c square t square is Lorentz invariant. Now we solve this. Since by Lorentz transformation x prime equal to beta x minus vt, y prime equal to y, z prime equal to z, t prime equal to beta t minus vx by c square. Therefore x prime square plus y prime square plus z prime square minus c square t square equal to, here x prime is beta square x minus vt square plus y prime square is y square plus z prime square equal to z square minus c square t prime square, means minus c square t prime is beta t minus vx by c square whole square. This equal to beta square x square minus 2x vt plus v square t square, y square plus z square minus c square. Here beta square t minus vx square means t square minus 2t vx by c square plus v square x square by c to the power 4. This equal to, we take common beta square from this and this. Beta square x square minus 2x vt plus v square t square, and here minus c square t square. We have taken beta common, minus minus plus 2t vx, c square cancel, here minus c square c to the power 4, here remains c square, v square x square by c square, and here y square plus z square, here minus 2x vt 2t vx cancel. So here x square, here x square, we will take common, this equal to beta square, here we take common x square, 1 minus here v square by c square, here we take common minus c square t square, minus c square t square remains 1 here, here minus v square by c square plus y square plus z square. This equal to beta square, here x square multiply 1 by beta square minus c square t square multiply 1 by beta square plus y square plus z square. Since beta equal to 1 by square root 1 minus v square by c square, so 1 by beta square equal to 1 minus v square by c square, and this will be equal to x square, beta square cancel, minus here also beta square cancel, c square t square plus y square plus z square. This equal to x square plus y square plus z square minus c square t square. Therefore, we get x prime square plus y prime square plus z prime square minus c square t prime square. This is also c prime, we may write, since c prime and c be same, equal to x square plus y square plus z square minus c square t square, since c prime equal to c, velocity of the light. Therefore, x square plus y square plus z square minus c square t square be same in every system, that is invariant. So x square plus y square plus z square minus c square t square is Lorentz invariant. Thanks for watching my video. If you are satisfied with my presentation and contents, then please click on like button and do subscribe my YouTube channel. Thank you.